Hi everyone, I am Khalil Ahmed, Assistant Professor of Physics, and the outline of my presentation is revision of module and unit test. Let us discuss the basic concept of conservation of angular momentum and energy. Now we can define the angular momentum L of the particle relative to the origin is the cross product of particle instantaneous position vector and its instantaneous linear momentum p, that is L vector is equal to r vector cross p vector. Now we define the torque acting on the system is the cross product of position vector and the force F, that is vector tau is equal to vector r cross vector F. And also we define the torque acting on a particle is equal to the time rate change of particle's angular momentum, that is vector tau is equal to derivative of angular momentum with respect to the time t. And now when a particle is moved along a curve, the rate of change of area set by the particle is known as areal velocity, which is the constant, and it is represented by the equation dA by dt is equal to half r square theta dot En cap. And next we talk about the central force, which is a force which is always directed towards or away from the fixed point. And now we discuss the Kepler's laws of planetary motion. That is the first law, that is the law of ellipse. It states that all the planets of solar system move around the sun in an elliptical orbit, with the sun being situated at one focus of the ellipse. And the second law of planetary motion is known as law of area. That is, the areal velocity is constant, which is nothing but if we draw the radius vector joining the planet to the sun, it sweeps out equal areas in equal interval of time t. And the third law of planetary motion is the law of period. That is, the square of the period of revolution of a planet is directly proportional to cube of the semi-major axis of the orbit, and it is represented by the equation, that is the t square is equal to 4 pi square divided by gm into a cube. Here the pi square, this total quantity is the constant, g is the gravitational constant, m is the mass of the sun. And we talk about the conservative and non-conservative forces. A force is said to be conservative if the net work it does on an object when the object moves in a closed pathway is zero. And we define the time period of oscillation of an object is given by t is equal to 2 pi into square root of m plus s by 3 into y divided by mg. Here m is the external mass added to the system or the spring, and s is the mass of the spring, and y is the extension produced when you add this mass, and m is the mass in order to extend these how extension will be take place in the spiral spring, and g is the acceleration due to gravity, and capital mass is used to oscillate the spring. Now we define the escape velocity, which is the minimum velocity which a body can be projected so it escapes from the gravitational influence of the earth. Here we neglect the air resistance, and it is given by the equation square root of 2gr, which is equal to 11.2 km per second. Now we define the stationary satellite. If a satellite appears to be fixed at a position above the certain place on the earth, it is called a geostationary satellite. And also we define the height of the geostationary satellite is given by h is equal to small r minus capital R. Here the distance between the surface of the earth and the satellite position, and r is the radius of the earth. Now we discuss the test concept. The maximum marks for the unit test is 30 marks. You have to answer the multiple choice questions. Answer any 5 of the following MCQs. The first one is, in the absence of external torque on a body, only kinetic energy is constant. B, only the magnitude of square of the angular momentum is constant. C. Both kinetic energy and magnitude of square of the angular momentum is constant. And D. Both kinetic energy and magnitude of square of the angular momentum are not constant. You have to answer any one of the following from the four given multiple choice answers. Now the next question is, which of the following doesn't use the application of conservation of angular momentum? Whether cat landing gently on feet, a diver performing somersaults while diving, a scatterer performing a fast spin, or fruit falling off the tree. The next question is, the angular momentum is dash in a central force field, whether it may be zero or not conserved or infinity or conserved. And the fourth question is, multiple choice question is, Kepler's law, second law, is known as law of orbit, law of area, law of periods, law of gravity. We have should be answered. The correct answer you should have to do. And the next question is the fifth question. A field in which the work is done in moving body along a closed path is zero is called electric field, conservative field, electromagnetic field, or none of the above. And the next question is, a geostationary satellite has an orbital period of 3 hours, 6 hours, 12 hours, or 24 hours. We have to write the correct answer. And the next sub questions is answer any 5 of the following questions, each carry 4 marks. The first question is, it is a descriptive type questions. We have to answer. Define angular momentum and torque. Obtain the relation between them. The next question is, from Newton's law of gravitation, obtain the Kepler's first law and third law of planetary motion. Derive an expression for the period of oscillating of a loaded spiral spring. The fourth question is, derive an expression for escape velocity in the gravitational field of the earth. Fifth question is, state and explain law of conservation of energy in a conservative force field. Sixth question is, what are central forces? Give 2 examples. And the last question is, obtain the condition for a geostationary satellite. Thank you. Thank you very much.